In the last presentation, I gave you this problem as homework, and now we will solve it. The function y is equal to a and b, or a complement and a c. I have just eliminated the last term b and c because this is redundant. This is redundant term. We can solve this by using the redundancy theorem. This theorem is also called as consensus theorem, and it is very important in solving the Boolean algebra. It is actually the trick. This is the trick in solving the Boolean algebra. And let's see what are the conditions and how to use this theorem. The first condition is there must be three variables, and we have three variables. A, b and c are the three variables in our function y. The first condition is satisfied. The second condition is each variable is repeated twice, and the repetition may be in the normal form or in the complemented form. There is no problem in that. Like a is repeated here and here. Here it was a, and here it is a complement. B is also repeated. C is also repeated. So all the variables are repeated. Condition number 2 is also satisfied. The condition number 3 says one variable is complemented and A is complemented, whereas B and C are not complemented. And the last condition says take the complemented variable. You have to take the terms in which the complemented variable is there. A was complemented, so I took AB, or A complement C. In the last term there was BC but no A, therefore I omitted BC. So this is how you have to use the redundancy theorem. It is a very simple trick to apply, and you can also prove it. So let's first prove it, then we will see few more examples on it. The function y is a and b, or a complement and c, or b and c. I can definitely write it like this. We will use this one in this step, a and b, or a complement and c, or b and c. This one can be written as a or a complement. I will use the distributive law now. I will open this and I have a and b and c, or a complement and b and c. Now you can see AB is common, so I will take AB as common, and here I am left with 1, and from here I will have C, whereas A complement C is common in these two terms, so I will have A complement C, and from here I am left with 1, and from here I will have a B. And you very well know that if anything is odd with 1, the output is going to be 1. So I have A and B, or A complement and C. This is what we got from the redundancy theorem, and you can also prove it like this. So this was our problem, and we can directly write the answer like this. We have to omit the term in which the complemented variable is not there. This is the proof. You can also prove it by using the truth table, that I will not do because it is easy and you can do it by yourself. Now let's solve few examples on the redundancy theorem. The example number 1, the function f is equal to a and b, or b and c complement, or a c. The first step is to see whether there are three variables or not, and we have three variables a, b, c. Each variable is repeated twice, and definitely each variable is repeated twice. A, b, b, c complement, c. The third case is one variable is complemented and c is complemented, whereas b and a are not. Take the complemented variables, so the reduced function will be bc complement. We have to take the complemented variable, that is c. So we have bc complement or ac. A and b is omitted. Let's see the second example. In this we have function f as a and b complement, or bc or ac, and this one is homework for you. You have to post your answer in the comment section, the value for the function f, the reduced value. And the example number 3 I will solve. The example number 2 is for you. A or b and A complement or C and B or C. In this again we have to check for the three variables. We have three variables A, B and C. Each variable is repeated twice. A is repeated twice, B is repeated twice and C is repeated twice. One variable is complemented. Yes, A is complemented, and finally we have to take the complemented variable. So if this is function f, we have A or B. I'm taking the complemented variable, that is A, and A complement or C, and this one is omitted because in this there is no A. Let's solve example number 4. In this the function is g and it is equal to A or B and B complement or C and A or C. This is homework for you. You have to post the answer, this one. And the fifth example is very important because it is different. We have A complement, B complement, or A C complement, or B complement, C complement. In this you can see all the terms are complemented except A. So we have to just follow these steps, and I will write function as A complement, B complement, or A C complement. We will omit this one because in this we don't have A. A is the only thing that is non-complemented. Initially we were looking for one variable that is complemented, but when all the variables are complemented and one variable is not, then we have to see the variable that is not complemented, and A is the one which is not complemented. That's why we have to take A, and A is there in the first term in complemented form and in the second term in the non-complemented form, so we took them. This is the answer. So please post your answers for the example number 2 and example number 4 in the comment section. This is all for the redundancy theorem. It is a nice trick to solve your questions because you cannot solve these problems directly by the rules, the standard rules of the Boolean algebra. You have to go through this process, and each and every student will not go through this process and they will say it is already minimized. That is not true. So this is all for this presentation. From the next presentation we will start the sum of product form.